तो स्टूडेंट्स, बात चल रही है बिट रेट की। हम लोगों ने ये स्टडी किया था कि बिट रेट इज नथिंग बट द नंबर ऑफ बिट्स दैट वी सेंड इन 1 सेकेंड इन अ डिजिटल सिग्नल। स्टूडेंट्स, हम लोगों ने डायग्राम के जरिए ये देखा था कि हाउ वी कैलकुलेट डायग्रामेटिकली हाउ वी कैलकुलेट द बिट रेट गिवन टू डिफरेंट डिजिटल सिग्नल्स। अब चलेंगे कुछ न्यूमेरिकल एग्जांपल्स की जानिब एंड विल सॉल्व सम एग्जांपल्स फॉर दिस बिट रेट। Students, in the first example, we have got an example where we need to download some text documents, and the rate that we need to download these documents at is 100 pages per second. And the question is, what is the bit rate or the required bit rate of the channel that we are going to be using? So we need to select a channel. In order to select a channel, we need to find out what is the channel bit rate going to be that we will use so that we can download this document at a rate of 100 pages per second. Students, in general, one page contains 24 lines. Every line normally has 80 characters. So, in this case, if we assume that one character requires 8 bits, then in order to calculate the channel with the required bit rate, or to find out the bit rate that we need to use on this channel to download this document, what we'll do is we'll calculate the total number of pages, which is 100 in this case. We multiply that with the lines per page, which is 24. We multiply that with the characters per line, which is 80, and then we multiply that with the bits per character, which is 8, and our bit rate is 1.536 megabits per second. So students, in order to download this text document, we need a channel that has got a bit rate of 1.536 megabits per second. Students, very interesting example. This is talking about a voice channel. हम लोगों ने पढ़ा था कि a voice channel, an analog voice channel, has got a bandwidth of 4 kilohertz. In this particular case, what we are assuming is that we have a digitized voice channel, and in this example, we need to sample the signal at twice the highest frequency. Bandwidth के concept को गौर करें. Bandwidth is equal to your highest frequency minus your lowest frequency. That is your bandwidth. So we need to sample the signal at twice the highest frequency, which is 2 samples per hertz. Students, once again, we assume that each sample requires 8 bits, and we need to find the bit rate. Students, in this particular case, because we need to sample at twice the highest frequency, we have to multiply by 4 kilohertz, which is our bandwidth. So it's 4 kilo means 4,000. Multiply by the bits that we require to send per character. In this case, it is 8, and this gives us a bit rate of 64 kilobits per second, or 64,000 bits per second. Students, voice channel has a bit rate of, a digitized voice channel has a bit rate of 64 kilobits per second. This is what we have calculated right now, and this is going to be coming into your way when you're talking about networking or data communication. This concept of a digitized voice channel and its corresponding bit rate, it's going to be repeated over and over again, and you'll see that. Students, before we leave this topic of digital signals, we're going to touch on an additional concept, and that concept is of bit length. Students, analog signal ke case mein, we had wavelength. Wavelength is the distance that one cycle occupies on the transmission medium. We don't have the concept of period for digital signals. We don't have the concept of frequency for non-periodic digital signals. So in this particular case, we use a concept that's called as a bit length instead of wavelength. Students, bit length is the distance that one bit occupies on the transmission medium. Instead of one cycle, we have got one bit now. Students, If you need to calculate this bit length, what we do is we multiply the propagation speed with the bit duration, and that will give you our bit length.